We're now looking at 4.4. We're analyzing quadratic formulas in this form here. We've got A's, we've got P's, we've got Q's. Those are called parameters. X and Y are the variables. Those letters that are not the X and Y are called parameters. Most important thing that we usually are talking about when we're dealing with parabolas is going to be either the intercepts or the vertex. So we're looking at the vertex in this lesson here. The vertex is your maximum or minimum point. And we're looking at the coordinates of them. So that would be in the first one. We've got 1, comma. Always make sure you look at what is your scale. 1, 2, and this is going up to 8. So that means this has got to go up by 2, 4, 6, 8. So we've got 1, comma 2. Same thing over here. We've got -3, comma -4. All right, graphing the first one here. And we're being asked to find the vertex using the calculator. So I punched it in there. Let's graph it. Oh, there it is. Let's find our vertex. Second, and on the calculate, left side. And we should be looking for second calculate. We should be looking for the minimum there. Number 3, good. There we go. Left bound. There we are. Good. Move it over. Right bound. Good. Arrows are pointing in. Awesome. And we get 1, comma 2. I'll put them down as A. We had 1, comma 2. Good. Let's go down to B now. And we put in 3x squared plus 5 and do the same thing. Let's find our vertex. Always a good idea to graph it so you know if you're looking for the maximum or the minimum. So again, on this one, it's opening up. We're looking for the minimum. And we need a left side. We need a right side. And yes. And we get, oh, that first one on the X, it's got the E -6. That's a 0, comma 5. Now we go to C. Let's plug that one in. As we plug it in, we should know right off the bat that A value in front is a -2. It'll be opening to the negatives. It's opening down. So we're going to be looking for a maximum on this one. Let's graph it and just check. Yep, that's the case. We're looking for a max. So we're looking down to 4. Left side and right side. Remember that when you first start, your cursor is going to be on the y-axis. So you know where to look for it. There we're on the left side of the vertex. Over to the right side of the vertex. And guess what we got? Oh, we got -3, comma 6. On to D, we've got 4. That's positive, so it's opening to up. So we've got a minimum. So second, let's calculate. We're going to find a minimum on this one. Okay, left bound, again, it's sitting right now on the y-axis. You can see that it's got 0 and 256. We got a long way to come down. Okay, so when we get there, that's our left side. Bringing it over, our right side, enter. We get 8, comma, oh, that's a 0. It's got that E -15. So last one with 8 and 0. Maybe you can start figuring out from the first 4. Hopefully you can see a pattern that's emerging. And maybe you can make a prediction even on E. Let's go through. We know it's opening down, so we're going to have a maximum. And make sure you move your cursor up to the left side there. Enter. Let's move it over to the right side. Enter. Arrows pointing in. Good. We've got, ooh, that rounds to 4, comma -7. Okay, and let's do the last one, F. Punching it into the calculator there. And graph it. We know that it's opening to the up. So let's do our second calculate. We're looking for a minimum. Move it over. Good. Bring it back to the right side. Good. And what we got? Ooh, negative 2 and again 0. Now hopefully you can see the pattern that's emerging. That these numbers are not just random. Interesting. And we got a 2. Where'd that come from? Oh, look at that. So hopefully with this next one, you should be able to read what's going on. But be careful. Notice that in A, it's an x minus 1. It was a positive 1. In C, x plus 3. It was a negative 3. So it seems to be the opposite sign within the x. So it's 9, positive 9, comma. Then let's look at where that 2 came from. The 2 was a positive 2. That was good. The negative 7 on E was a negative 7. Hey, the sign stays the same. 9, comma 1. We can read our vertex right off it. And that's why we call this form the vertex form. Now if we look at a graph of y equals x squared, here's a table of values. As soon as we go and we put x squared plus 2, what we're doing is we're starting with the x squared graph and we're adding 2 to it. So for every number, we're adding 2. Okay. Well, in the graph, that means that you're going to take the x squared and you're going to move it 2 units up. That's the key here. 2 units up. And that's a translation. Let's look what happens if we go x squared minus 3 now. We're going to take all those original numbers and we're going to subtract 3. So what that's doing is it's translating it down by 3 units. It's a translation, 3 units down. And you can see in your book, that's what the graph looks like. The first one, we went up by 2, and in the second one, we went down by 3. The whole graph is moving, including our vertex going up 2 and our vertex going down 3. Let's do the same thing with our parameter p. See how that affects it. And in this case, when we plug in our x values, we notice, oh, look it. We have as well the same values as we had originally, except the 9 no longer went with the 3. The 9 is now going through with a negative 1. What's happening there is that our x value has actually gone to the right 1 unit, or sorry, 2 units. Or in other words, if we look especially at the 0, it started at 0, 0, and it's now 2, 0. That's 2 units to the right. If we go x plus 3, let's just take that 0 and 0 line again, and we can see, oh, it's right up here. And that point 0 and 0 is now actually negative 3, 0. Or in other words, it's gone 3 to the left. There's what the graphs look like. Going to the right 2 or to the left 3. Be careful with this one in that it's going to the right 2, but there's a negative sign in there. Negative sign moves it to the right. The additive inverse. If it's a positive sign, it's going to the left. The additive inverse. Let's write that down. That's a key word. Additive inverse. In class, I'm going to explain the why this one's the additive inverse, where the up and down wasn't. Now, if we look at what happens with the a parameter, Putting a 2 in front doubles the value. That's going to be a vertical stretch by a factor of 2. That means in the graph, vertically, we're multiplying every point by 2. And it's going to make it narrower. Now, if we have 0.5 in front, that means we're going to have it half as big. Or in other words, a vertical stretch by a factor of 1/2. And on that graph, what we're doing is we're multiplying every one of those y values by 0.5, taking half of it. It's going to make it wider. If, however, we have a negative kicking it in front, what that's going to do is it's just going to make all of the values negative. Or in other words, it's going to be a reflection about the x-axis. And we can see that there, it flips them down. I'm going to change that one thing in there. This form is going to be called the vertex form of the equation. The vertex we can find by just looking at those translation values, the p, comma, q. Doesn't matter if it opens up or down, that's an a value, but the vertex is always right on p, comma, q. And our axis of symmetry. All you got to do with that is you take what's inside, x minus p equals 0. Oops, x equals p. That's how we find this axis of symmetry. It goes right through the x-coordinate of the vertex. All right, so this question now, number 1, determine the equation of the graph. Very important type of question. So we're going to start, we see, oh, it's a parabola. We're going to start with our vertex form. Y equals a bracket x minus p squared plus q. Now we've got to identify a, p, and q. P and q are the easy ones to start with. So our vertex is p comma q. Let's identify our vertex. Oh, right there. It's 4 comma negative 2. That means p is equal to 4, q is equal to negative 2. Let's plug those in. Y equals a bracket x minus p, which is 4. The minus sign's already in the equation, plus q, negative 2. So really we've got sitting there a bracket x minus 4 squared minus 2. But now we need to get the a value. In order to get the a value, take any other point, not the vertex, any other point. How about this one right here? They gave us 2 points there. I could use this one or I could use that one. I know those ones are exact points because they put the point on it. I'm going to find the coordinates of them. So let's just use the first one. This point is 2, comma, this one's negative 12, so that's negative 14. This is an x, comma, y. I'm going to plug them in for x and y. So negative 14 equals a bracket, oh, there I'm going to put in the 2 minus 4 squared minus 2. Hey, look at that. The only thing I have left in here to solve for is the a value. I can do my algebra and solve for a. Let's do it. So negative 14 equals a bracket 2 minus 4. That's negative 2 squared minus 2. Negative 14 equals negative 2 squared is positive 4. So 4a minus 2. Now all I'm going to do, add my 2. That gives me negative 12 equals 4a. Divide by 4. That tells me that a is equal to negative 3. I've got all that I need. Let's plug in to our equation the a, the p, the q. Y equals a, look at x, minus p squared plus q. Equation of the parabola. All right, the whole point of a question like this in number 2 is to get to be able to sketch the graph without using a graphing calculator. We're going to use these first part from A to be able to sketch it for ourselves. So first of all, we've got to say the direction of the opening. The direction of the opening is dealing with the A value. The A value is positive. That means A is greater than 0. If A is greater than 0, it's opening up. So we know it's got to be looking like this when we draw it. The vertex, hey, we can jump straight to the vertex really quick, very easy. It's the P, comma Q. The P is our, it says x minus 3, but that negative's already in the equation. It's the additive inverse. It's 3, comma 1. Then the equation of the axis of symmetry. Take that x minus 3 equals 0, solve for the x. X equals 3. That's where the additive inverse is coming through. Notice that we've got the 3 going on. Intercepts. X-intercept is when y equals 0. So we just plug in 0 equals 1/4 x minus 3 squared plus 1. And just start solving for the x. Don't expand it. Just start taking it across. Subtract 1. We've got negative 1 equals 1/4 x minus 3 squared. And the next one, multiply by 4. We've got now negative 4 equals, cancels off, x minus 3 squared. Next step, square root. Both sides. When you square root, we got plus or minus. But whoa, wait a minute. That's the square root of a negative number. That means there's no x-intercepts. Going through the same motions here, y-intercept is when x equals 0. Just plug in a 0 for it. So y equals 1/4 0 minus 3 squared plus 1. And let's work it through. Y equals 1/4. That's negative 3 squared. That's 9 plus 1. We've got y equals 9/4 plus 1. That's the same thing as saying 9/4 plus 4/4. So y equals 13/4, or 3.25. There's my y-intercept. And lastly, domain and range. Domain's always a nice, easy one. Domain is XER. It's a parabola, and it's not an application. Range, we just got to figure out, is it opening up or down? It's opening up. So y is greater than or equal to, and all we got to do is take our y-coordinate of the vertex and slap her in there. So that was 1. And of course, we can put on the end YER as well. Let's use all this. Let's do a sketch. Start with the vertex. The vertex is 3, 1. 3, 1. And it's opening up from there. I also know that my y-intercept was 3.25. 1, 2, 3, 4. So about there. There we go. Got a beautiful sketch. That's all we needed to do with it. Although I should, however, label it. Always label your graphs. There we go. Now, if I look at the equation, how could I tell, without even doing all the work, how did I know that there was no x-intercepts before I even did it? You didn't have to work it through to find out you got the square root of a negative number. You should be able to look at the equation, at the function, and be able to say, oh, there's no x-intercepts. How? Important question. We'll discuss that one in class. Do some thinking now. write something down. All right, we've been given some information now. Now we have to work through to be able to find the equation. Hey, there's my axis of symmetry. That's always the p-value. The axis of symmetry is x equals p. So let's write down our formula, our starting point. We need to figure out A, P, and Q. Hey, P is already done for us. P is equal to 3. We need Q and we need A. But we have some information. We have this point. That's x comma y. Let's plug it in. Negative 6 equals A bracket. Negative 1 minus P. Oops. I know that the P is 3 squared plus Q. So I've got negative 6 equals A bracket negative 4 squared plus Q, or negative 6 equals 16A plus Q. I've got two variables, A and Q. Can't do anything more with that right now. Let's go into the second point. Let's do x comma y as well with it. So then, y equals ax, that's minus 3 squared plus q, that's my starting point. Let's put in the x and the y. 0 equals a bracket 5 minus 3 squared plus q. 0 equals 5 minus 3, that's 2 squared plus q. 2 squared, that's 4. Oh, look at this now. We've got a system of equations where we've got A and Q, and A and Q. We're going to have to either use substitution or elimination. That was our system of equations again. So because they both have a Q that's the same, I'm just going to pull them and I'm going to use elimination. Line up your A's and your Q's and we're going to subtract them. And because I'm going to be subtracting, I'm going to actually make it easier on myself and change all the signs. 0, that stays as 0. Minus, minus, so that I can subtract. Or now I can add. So that gives me negative 6. 16 minus 4 gives me 12a. And hiya, those are gone. So now I've got 12a is equal to negative 6. Divide over the 12. And we've got left with a is equal to negative 1/2. We've got our a value. Now we're going to use either our equation 1 or our equation 2 here to plug the a in. I'm going to use equation 2 because it looks a little bit easier. And I'm going to plug in 0 equals 4 times negative 1/2 plus the q. And I'm just going to solve for q now. So 0 equals, that's negative 2 plus q. Let's add that 2 over. And q is equal to 2. Let's write those on the side. We've got p is equal to 3. We've got q is equal to 2. We've got a is equal to negative 1/2. So our equation is y equals negative 1/2 x minus 3 squared plus 2. Done deal. All right, let's finish off with a problem-solving one. Cable that supports the suspension bridge is parabolic. The horizontal distance between the ends of the cable is right there. We've got 140 meters. Good. And the midpoint of the cable is 14 meters below. So what we've got, just so you can understand, we've got, there we go. We've got a bridge supported like that. So we're asked to determine the equation to model this. Well, you know what? There's many equations that we could get. So we're going to try to find what would be easiest. Well, we need to put it on a coordinate grid. So we need x and y axes. So we could put the x and y axes there. We could put the x and y axes there. We could put the x and y axes here. So you have to decide, where do you want to have the origin 0 and 0? And my recommendation for something like this is to make it easy. Put the vertex at the origin, because then you know P is equal to 0 and Q is equal to 0. That's your vertex. It's going to make the math a lot easier all the way along. So now we're starting with the equation y equals a x minus p squared plus q, and we plug in zeros for the x, or for the p and the q. Y equals a x minus 0 squared plus 0. Y equals a x squared. That's a lot easier to work with. All we now need is another point, an x comma y. Well, we've got two other points. We've got a point here and we've got a point there. Doesn't matter which one you use. Well, I'm just going to use this one, the positive one. So that point is over to the right by half of the distance. If it's 140 all the way across, that's going to be 70. And then it's up by 14. So this point here is going to turn out to be 70, 14. If you wanted to use the point on the other side, it would have been negative 70 and 14. You can use either one of them. That's my x and my y. And then all we do is plug it in for the x and the y, same as we did in the other one. So my y value is 14 equals a 70 squared. 70 squared is 4,900. A equals 14. Divide over the 4,900. A is equal to 14 over 4,900. Take that to lowest terms. And my A value is 1 over 350. Last thing we do is make our equation. We know we got to this point, so y is equal to 1 over 350 x squared. Done deal. Again, finishing off, last two important questions. Dealing with what are A, P, and Q? What do those parameters do for you? What do they tell you about the graph? All right, good luck with that, and we'll see you in class.